According to the first law of thermodynamics, we know that the universe is made up of a system and its surroundings, okay? And the total energy of the system is constant. And any change in the energy, which is called the delta E, change in the internal energy, must be equivalent to the quantity of heat released during any process that occurs within the universe, plus the amount of work done, which is given as W. And as we know, this work done is equivalent to the opposing force, which is negative P times any change in the volume, given as delta V. In the bomb calorimeter experiment, we use a constant volume because we use either gas as a starting material or gas as a product, or maybe both. Okay, so in a bomb calorimetry experiment, which uses a bomb, we have an enclosed system in which all the starting materials and the products are contained within it, and the explosive nature of the reactions make us to call the setup as a bomb calorimetry, okay, or a bomb calorimeter. Now, because of the change in volume is zero, there is no change in the volume. Maybe there is a pressure change, but that's not going to affect anything because this whole term is going to be zero. As a result, the change in internal energy is becoming equivalent to the quantity of heat involved. So whenever we measure a combustion reaction's heat involved in the reaction, we are actually measuring the delta E. So how do you measure this? That's what we use the calorimeter, okay, the bomb calorimeter for. And we measure the quantity of heat absorbed by the calorimeter as something that is the amount of energy required to raise the temperature of the calorimeter by 1 degree, which we call as C-cal, calorimetric heat capacity, times how much in terms of degrees centigrade the temperature went up, okay, from initial to final temperature. That's the delta T. So with this, we can calculate the quantity of the heat absorbed by the calorimeter. Now, quantity of heat released by the reaction must be equivalent to the quantity of heat absorbed by the calorimeter with minor change in that, because a bomb calorimeter is an isolated system. So energy lost by the reaction is actually the energy gained by the calorimeter. So if you can find the calorimeter the quantity of heat absorbed by the calorimeter, and change the sign to negative, we get the quantity of the quantity of the energy released by the reaction. So when we burn something inside the calorimeter, the material burns and releases the energy, and that released energy is absorbed by the calorimeter. So we use the heat capacity of the calorimeter times the difference in temperature should give you the quantity of heat released by the reaction.